Hello and welcome. I'm Bill Wake. We're working on a basic interpreter. We've done a lot of work around expressions, but we've just started adding string type variables and expressions involving strings. And so we're going to have to work on some making our expressions handle more than just integers today. So I'm talking about values. All right, let's take a look. Okay. Excuse me. So last time we dealt with a parser on strings, and we did things like this, where you can assign a string to a body and so on. And we did a bunch of error checking. We added in to make sure that strings and numbers don't mix, okay? Because the numeric operators don't have definitions for them. Excuse me. And our normal pattern is fill in the lexical side, which is the tokens, recognize the low level strings and so on. Then we work on the parser to recognize the structure. And then we have to work on the interpreter. Well, let's see. So interpreter down here. Here's evaluate. So you give it an expression and it comes back with a floating point number, which is great for numbers and variables that happen to be numbers and operators that work on numbers. But we've added strings now, and obviously the string ABC is not a numeric value. It's not -1. We just put that in there to satisfy the compiler before we worked on it. But what this tells me is this notion that we just return floats is not strong enough. It was good for the version 1, but at this point we really need to generalize this to be more of a value, and where value could be a number or a string, and possibly future types as well. Excuse me, starting slow this morning. All right. So what I want to do then, before we get to actually evaluating something, we could print, ABC in quotes, and it should print ABC, but it's not going to, because it's going to come back with -1. So let's kind of do some pre-refactoring. We're going to convert this to a value, where value can be the basic types string and number. Okay. To do this, I'm gonna kind of do it a careful way, or a less disruptive way, maybe is the way to say it. I'm going to pretend things are a lot bigger than they are, and just extract out this body. So everybody who uses evaluate, we'll let them stay with evaluate for now while we get these values in. Oh, what's the matter? I should be able to extract method. Why not? Well, okay. Let's call it evaluate to a value, and function evaluate to value of expression is a float. All our tests should pass. All right. Okay, so we just extracted this. Now all the callers of this, they're fine. It's this I want to change. So I would like, I'm going to define a new type up here. Let's say enum value, and we may need some more to it, but the case we want to worry about is number. Okay. And I don't know, we have a number in our tokenizer, we have a number in our parser. This is yet another representation of number. It's a little confusing, I guess, but that's the way it is. And let's give it a float. So this number knows floating point, and here we can say let's do let result equals evaluate. Well, let's do equals value of value dot number of this. Okay, and I'm gonna nudge things around here and there, but at this point, I don't know if I can just say let evaluated equal that, let result equal evaluated. Let's see. Let case dot number let value result equal evaluated. Can I do that? And return result. Oh, how does that one work? No. Oh. I know I can do it with the switch. Well, yeah, let's do this little structure. Okay, so I get a float back. I'm going to wrap it in a value, and then this is variable should be number. Let result equals evaluated. Else, I'm going to say can't happen. Well, let's return minus 99 just to make everything hang together. Okay. So if I take this floating point number, wrap it up in a value, and then I peel the value back out to get the result and return that. Okay. I think that's, again, that should be a no-op at this point. But I'm going to flip things around and yeah, let's now let's make this return the value. Okay, so every place it returns, it's going to do the same thing here. Value.number of float value. Value.number of this. This one we'll get rid of in a minute, but just to get things together. So in effect, I pushed this value wrapper around each one of my evaluate two results. Okay. And again, I'm just doing these small steps for now. Okay. Now, let's see. This one is good, probably. I mean, it's just going to stay like it is. Okay. Value number, that one will change. String will change. This one, well, I think that's going to be We'll have to see on that one. Okay. Now let's find the callers. Okay. That's print, right? Yeah, it will be. I think a better name would be condition. And assignment. And then one basic test on these things. All right. Well, okay. Let's see if, let's move these to evaluate 2. Is that going to work? Okay, so it's really the operators. Evaluate expression. Yeah, this is, all right. Next thing I'm going to do, we put in this for the operators that are binary. Let's do something similar for the ones that are unary. Okay, so operators. I'm going to say operators 2, and that's because they take two values. And then let's make an operators 1. Map the token to a function from float to float equals, and then some map. Okay. And then the map is really this. So this minus operand. Okay, so if you get a minus, you want to do minus $0. Okay, and if you get a not, you want to do this stuff. Something like that. I think we still are in the numeric domain, so we'll have to do a little catch up there. Okay, dot not. Short return, let's just return the float. Okay. Type of expression is ambiguous. Okay. And I feel like I could inline that. I don't think it's too confusing. And then if it's the only return, you don't need to say return. Okay, the float of the not of int16 of the value. Okay. And now we can do the same kind of thing we did here. We fetch the operand, and then we're going to return this kind of thing. And again, I think, well, we only get one operand. And this is operators 1. Okay. The way we structure our trees, this really won't happen. So that kind of goes away. Okay. So you evaluate the expression, you apply the operator, and return that wrapped in a number. Okay, again, let's test. All right. Now, let's see. What I want to do is nudge everything towards working in terms of values. And our store is a good candidate, right? That is named a float right now. String to float. Okay. Let's see if we can get this to value. Like how much will break if I just do this. Compile time. Okay. Can I convert int? To a value. Can I convert value to expected type float? Okay, so it's the write and the read. All right. Let's. Oh well, this is actually. Is that right? I think we could take evaluate2 in this last case, right? Because evaluate2 returns a value, so that should be compatible. Okay. And now this case, the problem is if well, for now, if it's already a value, let's do value number of 0. Okay. We've kind of lost the type, so I'm looking ahead a little bit at the strings, I guess, but maybe I shouldn't. In this case, okay, I think we're back to green. Let's make sure. We're always returning a value. That's a good thing. The question is the default value based on the name. Well, I don't know. We know names ending in $sign get special treatment. But it feels like maybe the name isn't enough, that maybe the variable knows a type and can tell us that. Let's see what we got. All right, that's all green. So I think we'll check this in. We extracted evaluate2, returning a value, made store hold values. I think that's the bulk of it. Okay, now we're coming up on this fundamental thing, like what are we going to do? How are we going to manage the fact that some operators are string and some are numeric? And actually, I mean, we did our type checking earlier, so theoretically no operator will ever apply to a type that it didn't like. So it does know that it does know that these are numeric operators. Now the problem is we have some that aren't. Let's see. So the comparison ones, they can take strings or integers. So we're gonna have to figure out a way to manage those. But the unary ones, if you give me a unary expression, it's either not or minus. It's got to be a number. Okay, so operators wants a token dot operand. Operand is evaluate. See, I would like to. I would like to know. I'm not sure what I'd like. Somehow, operator subtoken, okay, that's looking up the minus or whatever, and apply it to operand. Well, operand is, its type is float still. This one. Okay, but we would like our operators to work in terms of values because they're going to be given values. It's just that it knows it's going to have floats. So maybe maybe our values could have an as float. That would help. I think I'm still refactoring with this. You can judge me. All right, but if this thing has a function as float, and it returns a float, of course. All right, and then if you don't work, we haven't dealt with runtime exceptions too much, so I'm going to keep it in this domain of kind of a can't happen thing, but guard let dot number let value equals self else let's print and return. Okay. Otherwise, we're going to. You don't need to let twice. We're going to return that value. Okay. So we're peeling out the value from one of those. Multiple statements. Closure. Did you mean to do? No. Is it guard? No. Guard case. I don't know why these just don't stick in my head, but they don't. Okay, so assuming this thing is a float, we return its value. Otherwise, we print and return. I think we're still in the range of, I don't know. I'm kind of projecting off and not letting errors slow me down, I guess. If number is value.number of float value. Okay, so we have 3.7, then that's the value that we use, and that's a number, right? Operand 1, okay. Operand here, we know it's a floating point number at this point because all our unary operators are floating point. Okay, so this evaluate 2. So I'm going to switch to use evaluate 2, which returns it as a value, and then I'm going to apply the floating point operator to it and wrap the result as a value. Okay, and again, I think that should be no change. Now, I think, can we make our operator return a value? Maybe this as float can move inside as well. Operand is a value. Yeah, let's see what we can do. Okay, so if this were value to float, it would have to be $0.as_float. We're moving it inside, and this would be $0.as_float. Okay, so if you pass in a value, where's our getter? Okay, we pulled that inside and made all the callers do it, which may be a bit much. Okay, I think this is going in a good direction. All right, so now I want to return a value. Okay, so this is dot number of this whole thing. And this is dot number of this whole thing. Okay. Oh, and this goes away. Okay, because it already is a value. Okay. Evaluate the token, get the operator back in the form it's in. Okay, I think that is good. Let's do the same change to our binary operators. I don't know if, okay, if the operands are these, then we have to change our operators to take values. And they can just use as float. Bool to float, okay. And I'm being very mechanical here, even though we can probably do it a better way. Almost the end. And, okay, these. Okay. Again, that should take care of that. All right, let's push this in. Probably don't need to say that if I make this value. Okay. We'll clean it up. Okay. I think I got them all. All right. I'm going to keep nudging this. I think we're still in a refactoring kind of mode here. I think if you take, since number requires a float, I think this cast is probably redundant. Okay, let's make sure. No. Really? Okay. We'll just undo that. Okay, I was hoping that was the case down here too. Yeah, so that's not going to work here either. Okay, well, oh well. This bool to float, let's push the number in there and make it do that work. Okay, bool to float returns a value. This is dot, well, I could probably put it on the outside. Dot number with all that. Okay. And now the dot number comes off. Guess I missed one. Okay. Okay, and then same thing here as float. Let's push the as float in too. So we're going to pass in a value to bool to float. X of float. Oh, interesting. Okay, we'll do what we can. We're going to pass in a value and a value. All right, And then we'll use x dot as float, y dot as float. All right, and then as float comes off those, conveniently marked in red, as float. I probably could have done this more efficiently. Since we're back to what we had at the start. Okay, what do we got up here? Dot. Okay. So we make bool to float work with values. All right, so at this point, who's calling evaluate? Well, one test. What's he doing? Let's let him call evaluate 2, and this will be dot number. All right. And oops, value conform to equatable. Okay. And the compiler will generate the stuff we need for that. All right. Everything else is inside. Where's my find? The definition. That's really calling evaluated 2. What's this one? Okay, that we got to work on, and that. Okay. I think we're due for a break, so let's do that. Take about a 3-minute break, and we'll come back and maybe well, I think maybe we can force these. Okay. All right. See you in about 3 minutes. Hi, welcome back. All right. Okay, so I think at this point, we know. Well, I think we've got these 2 places that still use evaluate. Format is used by print. Down here. Yeah, do print. And the other one was the assignment. Oh, that's an evaluate too. I miss good old find usages that would just work. Okay, find symbol. Okay, fine. That's the definition. That's the format. And this must be the if. Okay. Yeah, so I don't think we handle the situation with if. Let's see. Let's find the parser body. Here's if then. Okay, require then. Yeah, we return the if, but the thing we don't do is the error checking we did for the numeric stuff. Okay, so let's find an example. Well, and is a good one. Require float types. Okay, that's because or only works with floating point numbers. So we're enforcing the semantics down here, and then in the runtime we just do it, kind of thing. So let's see. I think we basically need to do a require float type on our if then. We got the expression. It really does need to be a floating point number at this point. So let's write a test. Okay, so we'll find our if statement. If missing then gets an error. Okay, yeah. All right, so let's make up a bad program. If $0, $a. Let's write basic, shall we? Okay, so I can't do this because $a isn't a number, and the number is usually like from a Boolean, right? So if a greater than b, then 43 greater than returns a 1 or a 0, and that numeric type is there. So we don't care of the result here, but this should say something about a type mismatch. Okay, and I guess we'll just run the whole. Oops. Oh yeah. Okay. This test. Well, we can do a build. This should fail. Okay, good. Empty. Yeah, so right now we don't enforce anything, but we should be doing a require, and we have one up here somewhere. Well, that requires a token. Require float type of an expression. Okay, so, and you can see the type mismatch. So this is the one we need. And back to if statement. Okay, so we get our if then. We expect a float type expression. If it's not that, then there's an error. Otherwise, we do the rest of the then. So I think this should pass now. Good. Okay. Where's our interpreter? Okay. So here we can switch to this if we treat it as a value now. Okay, so if it's not the number 0, which we know it's numeric, so there's no real problem there, we we do the jump otherwise. Okay, so that should be a no op kind of change. All right, and let's find, I think there's one more use of evaluate. Down here. Well, this one is going to be let's take the minimal change, which is like we've always assumed it's a float, so let's do that. Okay. And I think nobody's using it. I'm kind of blending my changes. Let's push what we have so far. So make if enforce that the result type is numeric, or the condition type. Evaluate 2. Now this should no longer be necessary. Okay, and we can delete this and rename this. Oops. Okay. So you can see this approach I used today, right? I extracted this out, worked this over to return values, had some compensating code to kind of deal with converting it back to what everybody else was calling for. But now we've switched things so everybody can just use evaluate and we're good. All right. Okay. Well, the other one we haven't, I guess we're going to work towards these string ones now. All right, let's see what happens. Assignment. Oh, we don't even look, do we? Right. So the value we get back, we just store that according to the name, but we probably, I think we might have already dealt with the assignment one. Let's go find the parser again. Assign. Oh, no, we didn't. Okay. So, oh, that's the let, but here's the assign. It must be a variable, right? Left type require equals. Okay, we didn't try. Oh, right type equals x. Oh, we did. Okay. So we pulled the expression types here. Let me move this down because we don't reference it till down here. Left type equals variable type, right type equals expression type. If they don't equal, then there's an error. Okay, that's correct. I think we might have a require types matching kind of thing. Let's see. Require float type. Require matching type. If left type not equal right type, throw error. Okay, so let's find our assignment again. Is that down here? This variable assign. Okay, if left.type not equal right.type, okay, so this is require matching types of left and what? Right. Left. Oh, variable and expr. That's a try. Okay, and then this can't happen because that is that. Okay. Require matching types variable expression. Okay. And then that's reflected in our interpreter. We assume that whatever value it gets back is safe to put in under the name. All right. Let's make sure this passes. Make type checking in assign use the require matching type method. Okay. Now the one place I'm not happy, well, we got the name. See, we're throwing away the type, which maybe is okay because we know it matches. But what about in here? Okay, value number float value, that's fine. If there's nothing in the store, see the type really, I mean, I don't know. It's like the default value here is not right for strings, right? So because we're assuming there, if we don't have it in the thing already, it should be an empty string, not a number. If the type is string, okay. Now here, this type, let's push this through. Okay, so I think this one. Right. This is going to be funny. I guess how can we let's make a test. Interpreter test. What if we print A? Okay, simple print. This is really print with numeric value, and we'll do the analog. I don't know. Okay, if it's line print, well, dot number is not the right value. We really need our string value to make this happen. So let's do dot string, and this is hello, and you should get hello. Okay, if you feed in 35 print hello, it should come back with hello. Seems like a reasonable request. Okay, and then why are you not complaining? I guess he should he'll complain at runtime. What do I know? Print hello works? I don't think it ran it. Okay. I don't know what that was. I got -1. Okay. Yeah. Now I'm. Let's. Well, one thing is strings should be value.string. String. And this should be value, and this should be let value. Okay, so given a string, peel out its thing and return it as a value. And then value has no member string. Let's go up there. Case number and case string. Alrighty. That's somebody's gonna complain. Build time, right? Somebody needs. We probably missed a place where it's. Oh, maybe not. Okay, I thought somebody was gonna be assuming they had the list of valid types when they didn't, but that's okay. Okay, so now our string comes back from our expression, and this will still fail because the format method is screwy. Okay, so format, yeah, so format assumes it knows what to do. So it gets the evaluate value. Let's pull this out. Let value equal, let result equal evaluate of value. Okay. This is result. Maybe this is input. And this is value. Okay. Now we need to do a switch. All right. So we got case.number. Let I want to call it value2. What is it? It's the number and case string of let string. Okay, so a number is going to do this. All right, and value of float. Oh, we've already peeled it out. Okay, so we got the number. And then the string, we're just going to return the string. Okay, and this should be a can't happen. I'm not sure what's. Okay. Right. Okay. So now we're saying when you print things, you got to know whether you're printing a number or a string and do the right thing. It's allowed to print mixed things, so I think this is really what's needed. But this should be doing better now. All right. All right. Let's see. Where else are we not doing things? I guess, well, what it comes down to at this point is relationals. Okay, so string expressions, print them and handle relational operators. Okay, and I think I would say we've done the first. May 26. We can print string expressions, and really we operate on value rather than float. That's kind of a background thing, but we did it. Okay, I think next is relational operators. And yeah, and I'm just not. All right, you can even see it bool to float here, right? This assumes float. We really want to have value. Now I could. What can we do? Well, okay, let's find the table. Operator 2 table. Okay, we don't care about plus, minus, times, divide, exponent, and so on. We only care about these comparison operators. And this is a numeric comparison. And really, we want to allow both. Okay. Let's do another test. I don't know. We had these program tests. They're kind of nice. We can operate up at the program level. I think let's do that. Program line after 10 is 20. Am I checking prints? Yeah. No. Oh, this is the program object. Never mind. I thought we had another set of tests. Did I merge them in? REPL test. I think I put them in expression tests. Let's see. Do we do that? Yeah, this is the kind of thing. Okay. That's a print. I guess we're dealing with relational operators, but this test is pretty close. Okay, let's print A less than B. All right, that should be true. So we should get a 1. I think what we're going to get is something blowing up at runtime because these things are going to assume as float means anything. Okay. Not equal to 1. Yeah, that's okay. So let's look at our method here. Right. So it converts these strings to floats. And let's find what that does. Oh, there's the -1. Okay. I'm going to need a quick break here. Hi, welcome back. Alrighty, so this -1 is the problem. And I think it really boils down to we need to accommodate the extra operators. All right, so this is op string, and it goes string to bool. Okay, and this is op float, and here we're assuming op float. Okay, now all the places that pass it in. The thing is, the string operator's got the same name, so you would think there'd be some easy way to make that the same, but I don't know one. Okay, but that's okay. We'll get it in there and then see what we want to do. Now, what I'm doing is making this thing handle both strings and floats, and you might think we could find a way to just separate them, and that may be true as well. Okay, I hate to have to duplicate this, but they really are different. Greater than or equal to.
Jamie, gotta go to work. I'll be back in a little bit.
Okay. Now, this should still have one failing test. Okay. And the failure is this thing always calls the float op even if the value is of type string. So we're going to have to look at the value. And we're going to just do X. Because we'll trust that the front end has made it, compatible. It knows the values. So if X is numeric, a number, let number, then we're going to do this. Dot number, op float, X is float, right? And then if it's a string, now we're going to do the right answer. Sorry, it's still dot number. But now we're going to call op string. Well, we're going to do this, basically. Modified. Okay, so we're going to return number still, op string. Actually, let's do this. I think I can do it like this. They're both numeric. Okay. Let number one. Well, number one is a float, so we can just use number one and number two. Okay. And then the case string, let string one and string, let string two. Okay. It's still number. We want to do op string. We're going to do string one and string two. I don't know what this is. Apparently it was necessary. Whoops. Op string. I don't think I need that. Okay. Case label can only appear within a switch statement. Oh, I think I have to do this. Does that work? Expected expression list. Value type value has no member number. That's not true. Let's go back to X. number X. Oh, this is number. And y dot as float because we didn't peel it apart. Okay, this return number op string of string. Y dot as string. We'll just make that one up. And then this is just junk. I don't know what that is. Okay. And we need an op string method. On our value. Oh, welcome, Rick. No fun. Hopefully they're dealt with. All right, so we've been working on making our value objects support both floats and strings, and we're just to the point of trying to make relational operators work. I'm not totally happy with it, but let's see if at least what we have solves it. I believe this should pass now. Yeah, okay. Let's run them all. Okay, so we made string relational operators work with strings. Okay. Now let's go back through. Okay, so the big change we made was bool to float. Used to take float operator float. Now we give it value, which holds floats or strings, two operators to deal with the two cases, and then another value. And we deal with those two cases. The question to me is still like, should I slice this different? Should I have had an equal string operator or something like that? And I don't know the answer there. The fact that this stuff is here that can't happen, that's a little weird to me. All right, and let's go down into the meat of it here. Okay, so you can see the call sites where we have greater equal. Okay. But I think the evaluate now, that seems right to me. The thing bubbling in my head still is the type of an expression. How do you get that? I don't think we're completely telling the story there, but oh, this is still wrong too. Okay. If you say print X and you've never defined X, it defaults to 0. But if you set print X dollar, it should default to empty string. Okay, so let's put a check in for that. So we'll test that a numeric variable defaults to 0. Do I have that test? To 0. Variable defaults to 0. Yes, we do. Okay, then let's test the string one. Defaults to empty string. Okay, so if you print $1, $1. It should print an empty line. Okay, and we did expect a failure there. It probably prints a numeric thing. 0. Yeah, okay, it prints this default value. Now, the thing is, well, where's our value type? I want to give a default value here. Maybe I can just do that directly. Returns a value. Okay. And then this is, we'll switch on self. Case number. No. Ooh. I'm not so sure that's going to work. Let's see. If it looks up, it gets a nil. How do we know this? Okay, so variable. Let's make sure variable. It has the type. Okay. So it's really type that needs this. And type is over in our parse class. What happened there? Isn't it? Yes. So the question is, where do we put this? Maybe it's an extension value on the interpreter side. I don't think that's unreasonable. Let's do extension type. And then this is func default value. I'm curious if this is legal. Case.string return value dot string empty. This should be value dot number 0. Okay. And then, are you going to compile? Are you okay? All right. And then down in here, where we're looking it up, okay, this is the type, and we'll use the type dot default value. Okay. Oh, build found. Expected type for function result. Oh, fair enough. Value. Cool. Okay. So we return the correct default value. For an unknown variable of float or string. Okay. And I think this belongs here because value is not a concept we have at parse time. So there's no way the type itself would know that. But it seems reasonable enough that we can ask it in this place. So that's good. All right. Now, what else was bugging me? Assign. Okay. I think that's looking okay. I think in the parser we did some work this morning on making if and print expect proper types, or sorry, if and assign. Okay. So I think this is done. All right. Yeah, now it comes down to what are we going to do? I don't know. Functions have been on my mind. Multiple statements on one line. That's a good one. Print with strings. We did that. Multiple expressions. Yeah, that's a good thing, but I'm not sure. Track line number of error messages. Yeah, we've been really bad about that. Sync. Okay. Yeah, I kind of feel like I want to consolidate some things, and maybe this is the time. There's this notion of a visitor pattern. Okay, so let me see if I can explain it. This probably belongs there. Let's take it. So the visitor pattern is used when you have a tree structure and you end up having multiple functions that want to apply to it. In our case, right now we have interpret. I could see kind of a pretty print being useful, and then there could be other ones like, well, compile is on my mind because one of my goals of this project is to write a compiler as well as an interpreter, and this is sort of like this growing thing of functions on the node, and we keep having to go touch node and if node and print node and assign node and go to node and all the node types. The visitor pattern is sort of it's a way of pulling out those various functions and making them on a separate visitor class. So the change is going to be instead of your nodes having all those functions on them, they have just one function that says accept visitor, and each node knows to visit that node's type. So if you the way an if node accepts a visitor is it calls visit if. And the way a goto node accepts a visitor is calls visit goto. All right. The visitor itself, then, it just defines what do you do for an if node, what do you do for a goto node, for an assign node, for a let node, for this, for that. Okay. It defines all those things. So interpret, in our case, we do interpret. We would say, what do you do for an if? Oh, I check the condition and I branch if it's appropriate. What do you do for a goto? Oh, I always branch. What do you do for an assignment? Well, I evaluate the expression and then store it in the store based on the variable name. And then the compiler would say, how do you compile an if? And it says, well, I compile the code to evaluate the expression, and then I compile the code to, um, you know, uh, run a conditional test, and then I compile code to branch here or branch there. Um, it's doing its own thing. Okay. So, and I don't know, I joke that I've put this pattern in that I've used it, 3.5 times because some of those times I put it in and then took it back out, because it 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 does make things a little trickier. Um, but I think we can also pass in additional parameters to node on the accept if we need to, and I think we'll want to do that as well. But I feel like this is probably a good a time as any to do this. It's kind of better to do it before you start getting way too many kinds of nodes. Well, actually, you like to have all your nodes in place, um, because adding a node is more expensive on the right hand side. Because now I have to go touch all my visitors. On the left hand side, adding a node is pretty easy, but I still have to implement those methods. So I don't know, maybe it's not that much different, but it definitely has a different feel that if you have your node types set, then adding visitors is just define that visitor, define the visitor, define the visitor. If you add nodes, then you end up going back and doing a bunch of work for every existing visitor. So it's a trade-off kind of pattern. If you only end up with one method on node, then it's kind of a waste of time to put this pattern in. So um, I think maybe that's the goal today, the rest of today. It's a moderate change. And I'd like to do it incrementally. Okay. Now, our parser is going to still build the same nodes. It doesn't care what methods it has on it. So we can add this except. Yeah, I think we can add except. We'll basically kind of do this in parallel a little bit. Okay, so that requires, let's see, not program, but parse. Okay, and for us, we have expression and parse. Maybe we can just do one or the other first. Which one's easier? Well, they're both about 5, right? Yeah. Um, what? Let's try this one. Okay. So what our pattern tells us to do is, well, we're going to have to define a visitor node. I'm going to say class expression visitor. Okay. And is it a subclass of visitor? Okay. So visitor, it's got to be there. And then this thing is subclass. Okay. And visitor. Actually, this does not belong here. Okay. So visitor is going to have a visit method for each one of these. Visit number, and it takes the node. Okay. The node is the expression. And this is a function. I forget how Swift handles abstract classes, does it? I feel like there's a way to do it. Class in Swift. Yeah, I think I can define a protocol or something. Yeah, there we go. Yeah, protocol. Okay. So visitors can be a protocol. And this is a function, visit number, visit string. Everything's going to take an expression. I think at some point I'm going to have to pass more stuff in, but we'll defer that for now. Okay, so here's an expression visitor. Okay, given any node type, it knows what to do. Oh, come on. Oh, okay. I got so used to my cases where I didn't need to do that. Okay, so since it depends on expression, I'm going to put it below. Okay. We got the expression visitor, and we said we would need to know how do you handle except on this thing. Okay. Now we're using an enum type. So I think we can just write our except, and it takes a visitor. Visitor of type expression visitor, and what does it return? I don't know if it needs to return anything. It's going to do stuff. Yeah, okay. Well, the job of is basically to call the visitor. Okay, so with each case, so we're gonna have to do all these cases again. I'll just steal this case statement because it lays them out for me. Okay, so if you have a number, well, we're gonna call visitor dot visit number with self. Okay, and then this is visitor dot visit string with self. There's no return. And we don't care about the insides. Okay. Now, none of this affects anything test-wise, right? We haven't done anything with it. The only gap I have, like, I don't know, if there is a return value, it would be nice to have it. And I think I can do this with generics. All right, but this is okay so far. But if we go, let's go in our interpreter. right? And where we're going to deal with this, it's kind of this, right? Evaluate expression. We more or less want to turn this into a visitor for expressions, and it's going to get the new value out of it. Um, I don't know. You can see why I talk about ripping it out. All right, so this thing returns a value. Our thing does not. The other thing is our code depends on store, and it just grabs it as a field. And I kind of feel like it'd be good to have parameters for it. Where is it? There. This meaning of what is a store, right? As you do functions, you need to make this more sophisticated to handle like nesting of names and stuff like that. And the evaluation definitely depends on that store, because a different store would have a different value. Let's see. So I kind of feel like what that tells me is value needs another parameter, and it produces a result type, which we probably care about. Now, I don't want to just drop it. I mean, I'm using it as it comes back, right? I'm combining it with others. So I need that value type. Let's see if I can push this into the right shape for it. I think I can. Parse. Where's parse? Okay. What I think it tells me is expression visitor needs a context type of some sort. And I think I can do this. How we protocols do not allow. Oh. More Oz syntax we're going to have to look at. Protocol and associated type. Well, what I want to do is make this context come in, and I also want to get a result type coming out. Okay, each method is going to accumulate into a result somehow, in some sense. But I need to do associated types. Okay, Swift protocol associated type. It's not that it can't be done. It's just one more thing. Right. So I say associated type, and then I can reference it. That doesn't seem so bad. Okay. Associated type. Whoops. Associated type context. Is that it? All right, let's try it. Result. Okay, take this off here. I would have thought the generic structure would work fine for this, but okay, it's still liking that. Okay. Context produces result. Okay, now that's going to bust something downstream, I'm sure. Yeah, all this stuff. Okay, my accept method. Oh, yeah, these types are tied together, aren't they? I guess this one belongs first after all, since expression depends on it and not vice versa. Oh, no, it is vice versa. Okay. But these things, okay. Except visitor and context, we'll have to pass the context in, and we're going to have to be generic on the context at some point. I think this is accept context like this. Okay. Now these things don't have results, right? Cannot convert value context to expression type expression visitor dot context. Visit number cannot be used on protocol expression visitor. Use a generic constraint instead. String. Generic constraint instead. Expression visitor can only be used as a generic constraint because it has self. Okay. Cannot find context. This one was, can I say expression visitor dot context? Generic parameter base. Ugh. Okay, let's try this again. See what the complaints are. Insert as expression visitor dot context. This message confuses me. Expression visitor can only be used as a generic constraint because it has self. Can I say this? Expected greater. Okay. Let's see if somebody's done this for me. Well, they're hard coding their result type, and they're not passing in a second thing. Okay, I mean, this is what we did basically. Accept visitor. Well, it's a little different. That's okay. That's kind of like our case. Yeah. What I want to see is Use protocol in generic type. Type alias stored. Well, it's not how I kind of want to work. Create a class or structure that wraps it. Yeah, any something. So they're using type alias instead of associated type. Init base of printer where base.t equals u. Well, it definitely crossed my mind that maybe some sort of constraint would help, but base. Yeah, that's what I was hoping for. Okay. Because of how collections are structured, you need to create a printable generator. Ugh. My printable takes. I'm not sure where this leaves me. I'm gonna rip it out. Let's look at interpreter again. And the thing is, we have a method that takes an expression. It's not on the node, so it's not in the way in that sense. So okay, I'm taking it out. Where's parse again? All right, so function type, let's take out except. Take out this. This is sort of a note for future self. It may not be right. Is that everything? Okay. Don't do a visitor after all. Dead end. Of course, I probably spent as much time drawing this as we did just now. So let me find a nice X to put across that. Just to remind us that okay, we're not doing that. Alrighty. Okay, what do we got here? Subscripts and functions, multiple statements. Running right to an output stream. That would be another one that's good to. Okay. The other thing I had in mind was we went through this stuff yesterday on the string constants, and we did this normalization in Lexer. If you were here for this piece, basically we split things on quote marks, and then we put them back together where we squeeze out spaces on the unquoted stuff and uppercase it and attach the regular stuff back in with quote marks again. But this doesn't deal with the case of a missing quote at the end. We kludged our way around it a little bit by putting this in first, but well, what occurred to me was we control the program when you put it in. We could normalize it as it goes in, and so we uppercase it and deal with all that stuff when it's typed rather than when it's parsed. And that might be a way to go. What I seem to recall learning somewhere along the way is that the micro basics, like they did something like that, and they rather than have the keywords be spelled out, that they would substitute a character, like imagine some sort of emoji character, or well, I'll show you what they have in those days, right? Some of their error messages do this. Yeah. So DD they use this ramp thing. Okay. Same thing here and so on. These two symbol codes, that you're supposed to kind of interpret, but you could replace the keyword with one of these graphic characters that's kind of like an emoji. Like this is, I think this is I think this is an airplane, half an airplane, the back half of an airplane. And somewhere else there's an emoji, or, there's a character that's the front half of an airplane. I'm not sure what that one is. I think they have a couple boats and whatever, just whatever graphic codes you can do in 7x9 squares or whatever these things are. And they would do that. They would substitute, like print would be question mark, and for would be, half a ship, and so on. And then they're parsing. They don't have to go scanning around for keywords at parse time. They just use the word that's there. Yeah, sidetrack. Do I want to do subscripts or functions first? Okay, I want to do functions, I think. Let's take a look there. And I think I do want to make interpreter, I want evaluation to work on a context, which is a store, Um, I don't need to make this more sophisticated just yet. I think I can do this. String to value. Okay. And this can be of type store. Okay. So the reason I'm doing this is I know, I'm looking ahead again, but we've defined strings, basically the variable to its value mapping, is how we keep track of the values of variables in a program, in a running program. And yet when I look at functions, let's see if we can find the definition of this thing. Here's def 10 f and a of v equals v times b. Well, v becomes, it's sort of like a new context, right? If you set reference v in here, you're referencing the parameter. You're not referencing the global variable v, where b is representing the global variable b because there's no parameter for it. Okay, and I think one argument. Yeah, you can only have one argument. So I don't necessarily have to use a fully sophisticated solution, but I mean, I was going to say real life or real languages, but in say Swift, when you open up a new context, you have local variables. Well, they're more or less stacked, and then they go away at some point. So I don't know that the store is going to have to be sophisticated enough to let us define variables. Now, I don't know if you could call FNB from here. I guess my guess would be you might not be able to, but if you could, then you might have the same problem because FNB might take a V parameter as well. And, you need to make sure you're doing the one for this one and not the one here or the one global. Okay. And so I think this is where I want this store to come into our evaluate function. Okay. So evaluate. What do we want to do here? Well, I want it to take a store. I'm willing to, let's make multiple steps again. Okay. So you can evaluate an expression with a store. Okay. And unused. Okay. This is really evaluate value and store, the global one or the field store. Okay. Nobody should care. Okay. I think this is a good move. Now, evaluate here takes the store and it uses it that you passed in. So if we pass in a different one at some point, evaluate can use it. So I'd like to make the callers all switch over. All right. But I guess I'm going to need a quick break again. Maybe 2 or 3 minutes. Even though it's relatively late. Yeah, let's take a quick break. We'll come back. We'll push store into the callers and go from there. Hey, welcome back. All right. So the goal is any caller of this one, we want to have it use the store. And let's find symbol. Okay, so this one is evaluating. I think we can just pass one in, an empty one. Make sure that's good. Okay. Need more symbols. All right. Okay, these are inside evaluate. Well, we'll just pass store down. store, store. This one is our format. We'll use the global or the field store. It may change. I don't know. That may be right on the long run as well. It's no more wrong than what we had, put it that way. Okay, and the store. Okay, and yeah, so if you do x equal x plus 1, you evaluate x in the context there, and then you change it here. Okay, let's run all tests. Good. All right, and then this should have no callers now. Wherever it got to. All right. Yeah. All right. What is gonna be? Okay. I think that's all right. So let's get the syntax for this thing. So def is def, and then fn a b c d e and so on up to z, one letter. And the right hand side. So we got parameters in the right hand side. So I don't think it's hard to match it. Kind of what it means is a little tricky. Again, I'm not quite sure what we want to do there. So the function should be stored somewhere, right? I mean, can we store it in our store? I think we can. Okay. So we don't really do anything. We got the def, but we don't have this function. And I don't know how you want to interpret it. I think we could treat fn as a reserved word and then look for a variable after it and then double check that it's only A through Z. All right. So Lexer tokens, we have def, but we don't have fn. Okay, so we want to add one for that. Lexer tests. Okay. Sorry, let's see what checked token is. It looks for the next token. I guess Lexer a program. I mean, if I say fn, let's try it. do that, then we expect the token .fn. My to-do is a little behind. No, we're good. Okay. Test failed. Good. All right. We have mechanism for that already. For fn, fn. Okay. And we'll run Lexer tests. All right. Now the parse. Well, let's see the parse. What is this gonna do? Maybe there's a parse. I don't know. I think what we would see, well, case def, if we do a define, right, we're saying case fn something, okay, which is a string, is going to equal, I think it's going to equal a parse. String and parse. The first is the function name, the second one's the parameter name, and the parse is the rest. Let's take that as a working thing. When we build, interpreter's going to complain because it doesn't know what to do with def. Okay, so down here. Okay, we'll just, I guess we could return def, not yet implemented. Okay. Build. Run everything. Okay, and let's start working on def. All right. So function test def defines helper functions. Okay, so if we let's see, it's more like this. Okay, well, let's call it D for double. We want some readable code here, right? Okay, so 25 def fnd of x is 2 times x. If you parse that, well, I'm going to be lazy, even lazier. I'm just going to say x. Okay, line 25, this is a def. The name of the function is d. The name of the parameter is x. And the body is variable x dot number. no doubt need some more parens. End of the line. Base parse has no member number. Parse. Oh, perhaps it's an expression. Yeah, I think it's an expression. Which can be variable string type. Okay. And this one closes that. This one closes def. This one closes the line and the assert equal. Okay. See if I got this straightened out. No. Type has no member number. Probably should. I'm reusing them and I'm inconsistent. That's not good. Okay. Let's see. What do we think is going to happen? Well, it doesn't know def. Okay. Do we get an error message? Yeah. Unknown statement. Right. Okay. So parser. Get down to statement. Okay. So if you see a def. Def. Define. And that's here. Function define. All right. This can throw. And it should return parse. I'm going to just pick a random one because we're going to stop here. All right, so I should get, well, I should at least consume my next token. Okay, so skip over the def and then let things just blow up. And that'll give us a place to start tomorrow. Tomorrow's Friday, okay. Right, so, well, we've made progress today. I mean, I think we got the strings basically working. We don't have string functions, but we've got at least string constants, string variables, and relational operators over strings, and you can print them. So that worked out pretty well using this new value type. And then I think we can, the visitor thing was a bust, but we can work on the functions. First definitions, then calls, and then we'll add in the system functions, predefined functions. And I think that'll cover functions. All right. Thanks for joining me today, and I hope I catch you again. It's 9 to 11:30 Central Time U.S., 10 to 12:30 Eastern, and 3 to 5:30 UTC during the week. So thanks for joining, and have a good evening, I guess, rest of your day. All right. Thank you. Bye-bye.